This may look like an ordinary steel bolt, but it actually contains a passive UHF RFID tag from Xerafy. Xerafy claims that their RFID tags not only work on metal, but embedded in metal, something our team has not seen before. Hi, I'm Lou Sirico, and in this edition of the RFID Network, we're going to put that claim to the test and see if the Xerafy tags actually do work embedded in metal. Stay tuned. Welcome to the RFID Network. I'm your host, Lou Sirico. In this edition, we're going to look at how UHF RFID technology can actually be embedded in metal items.
We've been given several different RFID tags from Xerafy: the Micro, the Nano, and the Pico. At under 16 millimeters in length, the Pico is the smallest on-metal tag we've seen. These are EPC Global Class 1 Gen 2 and ISO 18006C compliant passive UHF tags, all of which are designed to work embedded in metal. We've seen low-frequency tags embedded in metal before, but their read range is near contact. These tags can be read several meters away. All of the tags are able to be attached to or even embedded in anything metal and are fixed in place using a custom formulated resin. The tags are also designed to survive temperatures up to 480 degrees Fahrenheit. That's a pretty high temperature tolerance. With the assistance of partners such as Holland 1916, Xerafy has enabled a wide variety of RFID-enabled products, such as printed metal tags, tools, bolts, and zip ties. The RFID-enabled bolts are ideal for tagging just about anything that is put together with regular bolts, such as machines, assembly stations, and even construction. These tags are suitable for a number of applications, including asset tracking of military, construction, and even oil and gas equipment.
Here we are doing durability testing, and I'm with Matt Doppolito, owner of Body by Matt. Matt, welcome to the RFID Network.
Thank you, Lou.
Well, thanks for joining us.
Oh, it's my pleasure.
Typically, durable RFID tags have an Ingress protection or IP rating, which is a global standard for durability. But in the real world, when you're working in the construction, oil and gas, or even in the military, the RFID tags you use are going to get banged up. And that means impact testing, not just shock and vibration. That's why we've asked Matt, with the help of his sledgehammer here, to test us with impact. We've placed our IP-rated durable RFID tags on this metal plate. In reality, you might not expect someone to actually take a sledgehammer to an RFID tag. But in fact, this is everyday practice with pipes in the oil and gas industry. We're also trying to show that when a metal tagged asset impacts something else directly on the tag may not hold up. In the construction business, impacts like this are not uncommon when moving assets around.
We placed an IP-rated durable RFID tag on this metal plate. We slowed down our camera so you can see exactly what happens when the sledgehammer impacts the RFID tag.
All right, thanks, Matt. Well, obviously, a tag having an IP rating doesn't necessarily mean it's going to withstand a sledgehammer. This tag has been split down the middle. It's no longer waterproof, no longer dustproof, and chances are it's not going to survive in the real world for very long. Now, we're going to put the Xerafy RFID tag to the test. Since the Xerafy tags are embedded in metal and not sitting on top of metal the way the last tag was, we think they're going to hold up a lot better. So first, we're going to read the tag. Got it? All right, Matt, take it away. Ooh, quite a hit. Tag took it. And still reads. Definitely helps to have it embedded in metal. When our team does performance testing, we use a variety of RFID equipment. For these particular tests, we're going to use the CS462 from Convergence Systems Limited. This reader is powered by Impinj and uses the same technology as the Impinj Speedway Revolution. Depending on the test, we're either going to use a linear or a circular polarized antenna. When the tag orientation is controlled, we use a linear polarized antenna because it gives us longer read ranges. When the tag orientation is not known, we use a circular polarized antenna for better consistency. For our handheld tests, we're using the CS101, also from Convergence Systems Limited. We're going to perform a battery of different RFID read measurement tests. To measure the distances, we're going to use a laser distance meter that's accurate up to 1/16 of an inch. So, let's go take a look at the results.
We tested the Xerafy tags embedded in metal and affixed in place using a custom formulated resin. In our fixed position reader tests, we read the bolts from just over half a meter away, about 2 feet, while the micro tag could be read nearly 5 meters away, over 16 feet. Using our handheld, we read the RFID-enabled bolts at just under 1/3 of a meter, about a foot, and the micro at just about the same distance as the fixed position reader, nearly 5 meters or just about 16 feet away. It's important to point out that Xerafy tags also work on metal, not just embedded in metal, and achieve even better performance results. If you'd like more information, please see our accompanying article.
If you would like more information about the Xerafy tags, or to get a Xerafy RFID tag starter kit, please visit www.xerafy.com. You'll also find white papers and a comprehensive benchmark report.
That wraps it up for this edition of the RFID Network. If you'd like more information on the products you've seen, or to have your product reviewed, please visit us on the web at rfid.net. Thanks for watching.